Hi, in this video I will do an example for finding absolute max min of a function. The function in this example is 2x cubed minus 6x squared plus 6, and the interval is the closed interval 1 to 3. Before we start computing those ones, we have to note that f is a polynomial. So as a result of that, f is continuous everywhere, in particular on the interval 1, 3. And from here you see that we have both conditions um, for f having absolute max and absolute mean on that interval. It is continuous and the interval is closed, so f has both absolute max and absolute mean on this interval. Well, then let's find it. The steps you should remember. Step 1, find critical points of f on 1 to 3. 1, 2, 3. Well, okay, so we have to find the derivative of the function, which is 2 times 3x squared minus 6 times 2x plus 0, and that gives me 6x squared minus 12x. I have to set it equal to 0. Well, we can factor out 6x. That will give us x minus 2. So setting this equal to 0, we have either x equal to 0 or x equals to 2. Well, f has two critical points, but one of these critical points is not in the interval we are studying. So we will ignore that completely and we will take only this value to the second step. So this step 2 is evaluating f at 2 and end points, which are 1 and 3. So we have to evaluate function at these 3 points: f at 2, f at 1, and f at 3. F at 2, it is 2 cubed minus 6 2 squared plus 6. So this is 8 times 2 is 16 minus 24 plus 6, and that's 22 minus 24, which is negative 2. F at 1 is 2 times 1 cubed minus 6 1 squared plus 6, so it is 2 minus 6 plus 6. These two cancel and you get 2. And the third one is 2 3 cubed minus 6 3 squared plus 6, and this is, well, 27 times 2 is 54, and I have 9 times 6 is another 54 plus 6. So this cancels with that, we get 6. So now that you evaluated, everything is done almost. We are going to have absolute max of f on 1, 3 is you pick the largest value that we evaluated in part 2. So it's negative 2, 2, and 6. While the max goes here, again at this, which occurred at x equal to 3. And absolute mean of f on this interval is equal to minimum of these ones, while this is the minimum. So it's -2, which occurs at x equal to 2. Okay, so these are the steps, easy steps. First, find critical points. Make sure that you're picking the ones that are in the interval. Then evaluate function not only in that though at those critical points that you found in step 1, but also at endpoints. Then pick the largest one, that's the absolute max of the function on that interval, and pick the lowest one, smallest one, that's the absolute mean of the function on that interval.